In this video I want to explain how to factor trinomials of the form ax squared plus bx plus c. And to do this, let's start by expanding a product of binomials, 3x minus 4 and 2x minus 7. If we expand this out, we're showing a step here that we have been skipping over, where we right multiply or right distribute this 2x minus 7 into 3x and this negative 4. And if we do that, we get 3x times 2x minus 7 minus 4 times 2x minus 7. Then from there we can left distribute, and we get 6x squared minus 21x minus 8x plus 28. And then from there we can combine like terms to get our final answer of 6x squared minus 29x plus 28. Now, we want to actually work the other direction. We want to start with 6x squared minus 29x plus 28, and then we want to factor that into 3x minus 4 times 2x minus 7. And we're going to do the two intermediate steps of coming up with this, splitting up negative 29x into negative 21x and negative 8x, and then factoring this binomial and factoring this binomial into these two parts, this 3x times 2x minus 7 and negative 4 times 2x minus 7. And this is what we've been doing. We just haven't been showing it explicitly. So here's how it works, and then I'll explain why it actually works afterward. It's kind of an optional thing. So the first thing that we do, let's identify A, B, and C. This guy is A, this guy is B, and this guy is C. It's the coefficient in front of each term. It's a coefficient attached to each term. So 6 is my A, negative 29 is my B, because that's what's being multiplied by x, and my constant term is always C. First thing I'm going to do is I'm going to multiply A times C. A times C is going to be 168, and then what I'm going to do is I'm going to find two numbers that multiply to give me this 168 that add together to give me this B term right here, this negative 29. And it's a little bit of cheating right now, but we know what it's supposed to be, so we're not going to do all the guess and check. We know that it's supposed to be negative 21 and negative 8. What I could do is I could break down 168 into its prime factors and then start combining prime factors until I get what I'm supposed to. So I figure out that my two numbers are negative 21 and negative 8. I see those pop up right here. So if I'm working backward or upward, I'm going to be going up this ladder. I'm right here now. Next thing I'm going to do is I'm going to start factoring, and then I should end up with my factored form at the very end. So what I do is I take 6x squared, I'm going to subtract 21x, and then I'm going to subtract 8x, and I'm going to add 28. And it's important to realize that this is the exact same thing that I started with, is 6x squared minus 29x plus 28, because these two add up to negative 29. So I see that I haven't changed anything, not really at least. I've split something apart. I could very easily go back to that simplified form by recombining those like terms. But this gives me something useful, so I'm not going to do that. The first thing I'm going to do for this is I'm going to view these as two separate entities. I'm going to look at this as one chunk of stuff, and I'm going to look at this as another chunk of stuff. I'm going to factor out whatever I can from this first binomial. I'm viewing this as a binomial plus another binomial. I can factor out a 3. 3 goes into both 6 and 21. And also x goes into x squared and x. And then I look at what I have left over. What I have left over is a 2x, because 3x times 2x gives me 6x squared, and I have a negative 7. So if I distributed this, I would get 6x squared minus 21x. So I really haven't, again, I haven't changed anything. I've just changed the way it looks. And then over here, what I want to do is I want to recognize that I'm going to be either adding or subtracting something that's going to be multiplied by this 2x minus 7. So I look at this and I figure out, what do I have to multiply this inside by to get a negative 8x plus 28. And I know it's going to be a negative number. And I think about how I go from 2x to negative 8x. I have to multiply that by 4. And hopefully this will work out. If I take negative 4 and multiply it by negative 7, I get a positive 28. And I see that if I'm working upward, I am right here. 3x times 2x minus 7 minus 4 times 2x minus 7. So the final thing that I have to do is I have to recognize that I have two things that are kind of like terms. They're both being multiplied by 2x minus 7 by this blue binomial here. So what I can do is I can add these coefficients, 3x and negative 4. And if I do that, 3x plus a negative 4, 3x minus 4, we're going to multiply that by this 2x minus 7. And then finally we see that we end up back with our original factored form. So all we did was work backward. And I'm going to do another video where I show some examples of how to do this and some of the most common things that you'll see. But for right now, I want to do a sidebar. I want to show why this method actually works instead of just handing it to you and saying, here, just believe that it actually works. So if you want, this is optional, so you can stop the video right here. But if you want to see why this works, it has the potential to be a little bit confusing, but you'll see why we're able to do what we do. Okay, let me start with a random binomial. And this p could stand for any constant, and this q could stand for any constant also. And, I'm sorry, p is any coefficient in front of the x, and q is just a constant. And let's say we have rx plus t. Again, another linear binomial. And let's expand this out. Let's simplify this. Let's multiply these two polynomials together, and we get pr times x squared plus, I take px times t, and I get p times t times x. I'm leaving my variables at the end for this. These things are coefficients, and the x is really my only variable. So that's why I'm leaving my x at the end each time. And then I'm going to take this q and multiply it by r, and I've got this x also. And then q times t, I don't have an x. This is my constant term right here. I don't have any variable attached to it. Q and t, again, are just a couple constants, so those are going to multiply to give me another constant. Now, first thing that I want to point out is the reason why we multiply a and c together. AC is equal to 1/68. That's the first thing that we did. What I want you to notice is that if you take 6 and 28, that gives you 168. And if you take 21 and 8, that will also give you 168. And it turns out that way every single time. Here's the reason for it. We expanded this out. If we take our a term, our a variable, which is this, it's the thing that's being multiplied by the x squared, and we take our c, our constant, and we multiply those together, AC will give us PR times QT. Or if I put those in alphabetical order, PQRT. Now the next thing I want to see is that if I multiply this times this, the coefficients on my two x terms, I get PT PQR, which is the same thing as PQRT. So basically, every single time, what this is saying is that every single time, no matter what, if I've broken this down correctly, I'm going to get this times this, 168, that'll be the same as this times this. It just works out mathematically. I have the same product in both cases. This is exactly the same as this. So really what I want is two numbers that multiply together to give me AC. When I do that, what I'm hunting for is 6 times 28. I'm actually searching for these guys, this negative 21 and this negative 8, but I want them to combine together to make something very specific. I want them to combine together to make this negative 29, which is why I do the step that I do. That's why I have AC, and that's why I'm trying to get them to add up to negative 29. When I combine those, I get what I'm supposed to. When I find the two numbers that I'm hunting for, and I combine those together, if I multiply those, I get 168. If I add them, I get negative 129. That will end up giving me something that factors. I know that some of these guys, if you look a little bit deeper, these guys share a factor of P, and these guys share a factor of Q, which is going to let me factor it into this form right here. So that's the reasoning why this whole thing works. And if there were parts of it that you didn't understand, that's okay. It's really just the method that you have to understand, but really this thing does work out mathematically. It does do everything it's supposed to. Start by finding AC, and then find two numbers that multiply together to give you 168, this AC, and add together to give you B, this negative 29. List those as your coefficients on your X term, and then factor out as much as you can from each binomial. And then at the very end, hopefully you've gotten something 2x minus 7 and 2x minus 7. Hopefully you've gotten the same thing in each of these groups, and that will allow you to factor the entire thing the way it's supposed to. And it's very quick and it's very efficient, and it's much better than any other method I've ever seen before. In the next video, we'll talk about how we'll look at some examples for how to do some of this factoring, but really that's the overall idea for it.